the Linux kernel. In this nugget, we're going to continue our discussion of the Linux kernel. We'll learn how to customize a kernel, and then we'll go through the necessary steps to compile and install the kernel from source code. Now, if you're going to follow along with this module loader, then you're basically going to build a monolithic kernel. Okay? Feel free to build a monolithic kernel. Nothing's going to be wrong, but a modular kernel is going to perform better because it's going to eat up less resources in the system like memory and so on. Okay, so I'm going to leave all those checked as yes. That's important. Alright, so processor type and features is where you can set very low-level specifications for your processor, low-level kernel modules. General setup, you can go in there and look around and see what's in there. It is what it says, general setup for the kernel modules. Binary emulation of other systems. This has to do with whether you want to be able to run binary code from other sorts of systems. So do I want to run binaries from like SPARC stations or something like that? Then I could set that up under this particular heading here. Going down, parallel port support, pretty obvious what that is. You're configuring modules for your parallel ports on your system. Parallel ports, typically you plug in printers to there. You can plug in disk drives, things like that. Okay. Then multi-device support like RAID and LVM. If you're going to set up RAID array of disks or logical volume managers, then there are kernel modules in there to support that. Networking options, you know, all the various network cards and network drivers and so on you can configure that in there. ATA IDE support for other kinds of disk drives other than SCSI disks. So even though the primary, let me click on that one. Even though the primary disk on my system is a SCSI disk, I would still say yes here that I want to include support for these other kinds of disks like IDE disks because you know, in the future I might add another disk to my system and then I can add an IDE disk and I'll have the support already there to build in. When you go to configure your kernel, make sure that you think, you know, a little bit ahead here. Okay, don't configure a kernel that is going to go through, tell us what it's running, and all of this output is not necessary to go through line by line. If you want to capture all of this and see what it says, you can pipe all this stuff out to a file and capture it all if you want to see it line by line and see what's going on. Most of the time I just let this run, and then if there's errors, you can always go back and execute these commands again and you know, pause the screen or pipe the output to a file so that you can see exactly what's going on. I'm just going to pause the video until this dependency information is all done. Okay, so now that make dep has run and all the dependencies are set correctly, the next thing we do is we issue the make clean command. And now this will prepare the source tree for the actual compilation. Alright, so I'm going to issue make clean, and then again, a bunch of step is going to be another make command, make bz image. So we say make BZ capital I MAGE. So make BZ image, and now we're actually building the actual kernel now. So I'm going to do this, and this is going to take a while. I'm just going to pause the video while this is executing, and then I'll come back when that's done. Alright, so then once make BZ image is done, then we execute make modules to make the modules that we configured. And now this screen is going to go on for a little bit, and then once that's done, then we will install the kernel modules with the command make modules install. Alright, so I'm going to pause the video again, and we'll come back once make modules is finished. Then the next step is we run make modules install, and this is actually installing the kernel modules. Even if you didn't build any, you still run this command. Okay, just to give you an idea here, the amount of time that's elapsing that I'm pausing on the video varies from processor to processor. Depends how fast your processor is, how much memory you have. Compiling is a pretty computationally intensive process, and there's a lot of work to be done, a lot of files to be operated on, and so on. So I can't give you an estimate and say, okay, it's going to take 15 minutes on your machine or tools so that we can customize and compile the Linux kernel from source code. I gave you that whole list at the beginning on the whiteboard of the GNU C compiler and the C preprocessor and the Tickle, the scripting language and things like that. All those things have to be installed to follow along and actually execute what I did in this nugget. Okay, and then just as a summary, the steps to compile and install. First we did make mr proper to clean up the directory tree. Make xconfig was the tool that we used for customizing. Then make dep made the dependency information. Make cleaned up the directory before the actual build process. Make bz image was actually building the kernel. Make modules is what we used to build the modules that we configured. And then make modules install actually installed the kernel modules. And finally, make install is what copied the new kernel and the associated files to the correct place, and then it also ran a couple scripts that created the initial RAM disk image and altered grub.conf. Okay? If you run into problems with this process, refer to, I think it's Appendix A of the Red Hat 8.0 manual. If you're using Red Hat 9, look in the appendix of that manual for under building a custom kernel. And you'll see the same steps they follow there, and they also give some ideas on how to go about troubleshooting problems if you have them during this process. All right, well, I hope you found this nugget informative, and thanks again for watching.